if you were forced to reduce that a bit, that mid to late flower is really when you're going to want to do that. Don't starve it during flush. Also pair with those microbes.
Pair with the microbes. That's one of the biggest things. If you're doing microbes, don't do one without the other. That's one of the big things. Because you got to feed the microbes.
And and again, remember, guys, this whole, that breaking that sugar down at night and that dark respiration and everything else. Well, guess what?
This is a great tip.
This is a great tip. This is something.
If you take anything away from this episode,
this is something we came through. So,
we're Jug Dealers. We're the podcast you need in your feed. Teaching the game like you never seen. Jerin, Gabe, GRAMBO, true OGs. Masters of the globe, set your mind free. From Denver, Colorado, where the data's green. We set the data points for the SOPs. Jug Dealers Podcast, yes indeed.
Hey, everybody. Welcome back to the Jug Dealers Podcast, where we discuss all things cannabis and lifestyle related, brought to you by the good people at 5-8, and as always, available at jugdealers.net and jugdealers.shop. And keep an eye on the website because we are constantly adding
of new stuff up there.
Different things to the website. As we get it built out, there's constantly, and not for nothing, we just have, different partners.
Well, exactly. New partnerships that are coming up, new things that are on the website. And in fact, we're going to also start dropping some exclusive deals. I can say just very quickly, just a note too, we did have a very short and slight Jug Club membership that was opened up, and we kind of had some things that got messed up, but rest assured the folks that signed up, we will be in contact very soon, let you know what's going on with that.
It wasn't anything personal.
It was payment issues.
It was cannabis shadow banning.
Yeah.
And not even shadow banning, straight up banning.
Yeah, a little different.
They called us a cannabis business.
Can you believe that?
I'm like, we're not a cannabis business. We just talk about cannabis.
Yeah, I was stunned. So anyway, I just, all you guys, all you faithful listeners, thank you very much for coming back. And you VIP guys, we will get that open back up. We'll just have it better figured out before we open it up this next time. So, rest assured that's not over. Also, you can get samples at jugdealers.net/samples. We do have packages that are available. Very easy to do. Fill out that grower's form. Pick your samples. They come out to you real easy, real straightforward now, much easier than the former system that we had. And then also we do have a bookings page. So, you can find out where we're going to be out and about around the world and around the country. And if you do have any requests, you want to come by for a cup, or come by the shop, or come by the grow, let us know. And any of you commercial people, don't be afraid to reach out as well. That those sample packages might look a little bit small for commercial, but feel free to shoot me a comment through the Jug Dealers website, and I will be in contact with you. So without further ado, we've got a fun one for you today. We are going to talk about we're going to talk about carbohydrates and specifically why carbohydrates are important in cannabis, what they mean in cannabis. This is one of those ones that's not going to fall under your plant essential, right?
No, but it's important.
And plant beneficial, right? So maybe it doesn't come under the 17, but and we do have some cool products within our line as well that, again, are obviously available that we'll talk about a little bit later on in the episode. But we really want to start about, very specifically, with this first piece here, why don't you talk, Gabe, just a little bit about why are carbohydrates, important in cannabis?
Reality is they are the primary energy currency in the plant.
They're the currency.
Simple sugars like glucose, fructose, and sucrose, they power all the physiological processes.
Right.
So that's one of the things where, again, not essential in the fact that it's, doing what MPK is doing, but it's still helping things move along.
Well, and obviously, cannabis or plants for that matter in general, what are they doing? What really is photosynthesis? Well, photosynthesis is the production of, carbohydrates, sugars. And that, again, that's one of the reasons why it's truly, the currency within the plant. Now, being able to give plants, in addition to what they're able to use in photosynthesis and kind of use on that ATP level and everything else, we can provide them for building blocks and also, terpene, enhanced terpene production, SAR resistance, things like that, which that's what we're really going to get into specifically. Again, so what are sugars, specifically, photosynthesis sugars used for? Well, we already mentioned energy, right? ATP, which is, what is it?
Adenosine triphosphate.
Adenosine triphosphate. That is correct. Nice work. And that is done via cellular respiration, going back to the old, high school science books. Also for structural support. So cellulose, pectins, things like that.
those cell
stability.
walls.
Yep. And then signaling molecules. And this is, I think, one of the more interesting things that we're going to talk about.
This is one of those kind of like, like you always talk about, kind of hard to measure.
Yep.
Because, and obviously we can measure Brix levels in plants like that. But even then, there's some things where you always talk about, you're like, there's a bunch of things we have answers for. Then there's a bunch of things we just kind of like,
we don't know.
We don't know.
But let's say for, as an example of, with these signal molecules, sucrose actually, regulates flowering and branching and helps signaling those kind of things, right? Just as an example. And that's one of many things that are going on. And again, we know a few things, but we surely don't know everything. Starch storage, interestingly enough, does happen in the chloroplast, but that is pretty short term from what I understand.
That's very short term.
Yeah. And then roots, that's really more long term. So I think that's somewhat common knowledge that people have kind of gone into some of the more physiology of plants, understanding that, roots are important for obviously a number of reasons, but it's not just water uptake, right? There's a lot more that's going on there. And one of the other important things is long-term storage of sugars.
A big thing that, we always talk about and why it's so important is really the role of carbohydrates during flowering.
Yeah.
Because flowering demands, a lot of carbohydrate flow. Sugar is transported via the phloem to the sink, which is basically the buds.
The buds, yeah.
You know what I mean?
So you're going, point A to point B, right?
And
so
it's all tied, and it's all tied together, Yeah.
And one thing, and I just want to mention it because one of the very interesting thing is too, as you have some of those diurnal things that are going on.
Wait, say that word again. Diurnal?
Diurnal, right? Because we do have not only diurnal, which is day-night temperature variation, but obviously diurnal photoperiod, right? So you have a day and night, right? We have obviously a dark and a light period. And just, I want people to understand though, too, that these processes do change and are different from night to day. And I meant to kind of go over this a little bit before, and I kind of spaced it before we got into the next segment, but that's okay. But one of the real big examples of that is really the nighttime breakdown of these starches and fuels actually start once photosynthesis stops, which makes sense, right? It's kind of the yin and the yang. It's all building up during the day. All this photosynthesis is happening. You're having the short-term storage, into the chloroplast, just boom, 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 making that readily available. And then once the light goes out, now the processes within the plant shift to those nighttime activities, right?
I think that's a process and a part of the cycle that a lot of people overlook.
Well, yeah. And I mean, and even
people, I think lights are off. People are checked out.
Well,
they're not thinking about and
all these important things are actually happening at that time. And then, of course, we've talked about this, and we won't get a whole lot. In fact, a little bit of a
teaser. We got the airflow.
Yeah, we do have the airflow
coming up.
Episode and talking about what does happen when the lights go off and things like that. But anyway, I think this is.
I think about it like working out. When you're working out, you're breaking things down, and it's actually the nighttime sleep, the rest, and healing.
The sleep, yes. And again, talking about sucrose, glucose, fructose, which are these short sugar chains, very available, easy to use sugar chains. Sucrose seems to be for good, bad, or indifferent, very, very prevalent in a lot of these signaling processes, but specifically, in the flowering type areas where you're talking about specifically trichome production and flower initiation. Which obviously is very important.
Well, and carbs, they help regulate gene expression as well.
There you go. So. And that actually go into that a little bit more, because I think that's something that as we went through this, I was kind of like, And this seems to be a complex and even quite possibly a newer area that they're trying to find more information. Again, we have little bits of information at times and not so much at others.
Well, they say that it can help regulate expression during the reproductive development. And then as well, upregulation of the MADS box genes.
MADS box genes.
Responsible for flowering identity. So again, that's more, it's almost like it's driving.
So, and when we're talking flower identity, is that going to be more, is that going to be a more morphology thing? But maybe even number of petals and
phenotypic expression.
Sure.
Genotype times.
And I wonder if that even, and I wonder too, in flower identity, could that possibly be even pistils and stamens, right? So could it even be like a male female type thing as well? Again, I'm sure. Let's see what you got there, Josh. The MADS box. That's MADS is a conserved sequence motif. Love the word motif. The genes which contain this motif are called the MADS box gene family. The MADS box encodes a DNA binding MADS domain. The MADS domain binds to DNA sequences in high similarity to the motif. This is where it really gets fun. Oh, I'm not even going to try and read through that shit. So again, this is very complex stuff. If you want to go down that rabbit hole, by all means, we just like to kind of touch on the top. But the reason we wanted to bring that up is carbs are involved in really complex stuff. They're not just sugars. So it's way more important than that.
It's funny because talking to the Diamond Mine lately, he's been using a lot of these ferments and stuff. Similar, he's been using...
These are the available ferments, available sugars.
He's been using the carbonaria and stuff. And he says, it's very timing dependent, in the plant. But when you do it, it's almost like hitting a turbocharger.
Sure.
And it's very, it's important when you do it, how much you do it, and the frequency you do it.
Well, and dare I say that a deficit in carbs is going to lead to poor bud set, lower terpene production, and
lower cannabinoid expression.
There you go.
Yep.
So, if that doesn't mean something, then I don't know why you're growing.
Well, and it's funny because I'm not going to mention anybody, but a partner of ours just harvested something, and I know they don't use any carbs or anything like that, and the numbers were lower than they should have been. Because they're just using a standard base feed.
Sure.
No adjustment.
Well, and again, that's why we like to talk about plant essential versus plant beneficial. You know what I mean? Again, does a plant need all these beneficial things to get the expressions that we're looking for? Maybe not, but we're oil farmers. That's the other one, Josh. Mark that one down. Oil farmer. Sorry, we've been coming up with new stuff for the website.
The new the not for nothing shirt, the plant janitor.
Sorry, mark that down.
And what was it again? Say that.
Oil farmer. Oil farmer. So that we got some new stuff that's going to be coming on the website. So keep watching. But the reality is, I think some of these simple things and the things that people really need to keep in mind is positive stresses, which is what we're looking for, because we really are oil farmers in creating those positive stresses, such as, high light intensity to create sunscreen. Well, oil is a bit of a sunscreen, right? Yep. Or creating, if not actual desiccation, the essence of desiccation, if you will. So the plant goes, oh shit, I need to push out more oil to protect itself, right? Or even like our wonderful product, Winter Frost, which actually makes the plant think it's going to frost, so it pushes out more oil, like an oil sweater, right? If you literally look up trichome in the dictionary, it's just a plant hair. It's not super specific. Obviously, there's different kinds of trichomes, you know what I mean, in different structure. But the reality is these are
tomatoes have trichomes.
Lots of plants have trichomes. It's a plant hair.
Right.
It doesn't say a cannabis plant hair. It's a plant hair. So these things you see throughout nature. Now, what we've done is we've found that it has positive properties, and we figured this out quite some time ago. And then we started selecting based on the oilier plants. Right. It's just the same thing like, cabbage, broccoli, kale, they're all cruciferous plants, right?
Well, and none of this stuff.
But they've been selected over time to be that expression.
That's what I was going to say is all the things we look at, corn, broccoli, whatever, they didn't look like any of the things 100 years ago.
No.
You know what I mean? So I think that's where, and, as we've stated, the leaps and bounds we've taken with cannabis in the last 40 years,
sure,
is kind of way quicker than what we've done with all kinds of other crops.
Well, and you got to figure that's been done essentially, anecdotally. Anecdotally, actually. Thank you, Mr. GRAMBO. Most of it's been done outside of any kind of, verified science, per se. So there's been very little opportunity for that. Obviously, we're getting more and more of that now, but you got to think all the advancement has basically been in basements, for lack of a better term, for a really long time.
Can we talk about carbs and the dynamics between carbs?
Yeah, we can, but it looks like the GRAMBO wants to talk about trichomes a little bit.
Are you going deeper?
He's curious.
When I learn things, I dive them in. I go, is that right? I actually didn't know that. You are correct, sir.
Well, I mean, I try not to talk about things I don't actually know, but just kidding. But I like to point that out because I think that people try and overcomplicate it. You know what I mean? And again,
these things aren't unique to cannabis.
That's my point.
And I think that's where people try it and they're oh, this is unique to they all have. No, mitochondria and cells and the Golgi apparatus.
And we know strains are called cultivars. Leave us alone.
Strandivars.
A strandivars.
So, again, I like to, I do like to point this out because at the end of the day, the biggest point to me is that no matter what you're growing, it's very important to understand what is of horticultural significance.
Yeah.
Right. So if it's a strawberry plant, it's a strawberry. It's not the basal part of the, portion of the plant that might be huge, but if there's no strawberries, what do I care? Right. So it's, on a squash plant, it's not the leaves.
Ultimately, the strawberries need to taste good.
Well, they do need to taste good.
They can look
great. Well, truly, it's not only how many is there, how big are they, and how do they taste. But that's neither here nor there. Anyway. Point being, know what you're growing. And in cannabis, we are growing oil because that's what's of horticultural significance. Whether you consume it with or without plant matter, which both Gabe and I tend to do either or. But and some people have their preference, but reality is even with plant matter, it's oil that we're after. Yep. So again, it's just all about horticultural significance. And I love, bringing that up. Hey, everybody. Didn't want to interrupt the flow of the conversation, but did want to remind you that anything we talk about that are our products, you can find at jugdealers.shop 24/7 online. Go and get it. Support us. Help us, continue doing what we're doing. Jugdealers.shop. Thanks a bunch. Now back to the show. We had jumped back a little bit, but I did like to make that point. And I'm glad you always kind of remind that because I think it's important to understand what we're doing. But let's talk in the next segment specifically, and I'll let you run with this a little bit. Roots,
baby. Give me the roots. Give me the roots.
So specifically the microbial
and this is where
carbohydrate
dynamics. Where we're telling you, this is why we're always saying about the hypochlorous because ultimately, the carbohydrates are going to give you these root exudates. These root exudates, they are going to attract the microbes like the trichoderma and the mycorrhiza. And that's where
Pseudomonas.
Yeah. And that's where all the magic's happening because again, these are helping break down elements so they become available to the plant. It was just funny because I was on Dude Grows a couple of weeks ago and we were talking about, and I had I had a brain fart because I'm sitting here and I'm not thinking to myself, no matter what elements you have, N doesn't come as N. P doesn't come as P. Well, they're all bonded to all these different things.
NO3-, that's the uptakeable form, for example, of nitrogen. Well, hold on now.
Yeah. So how do you get from NH? How do you get from NH3 or NH4 to that?
NO3-.
Well, because these little microbes are doing their thing, but ultimately the sugar helps feed these microbes. So when they come up, they've had a Red Bull. Well, and they're like, let's go, baby.
And it's a symbiosis. People got to realize that the plant has to be able to provide something to get something back. Mm-hmm. So if a plant is not rich in carbohydrates, as an example, being the example that we're using, then you're going to have, so that means it's going to have less root exudates, which means it's going to be less advantageous for these things to actually work with.
And that's when you have to pump these things full of salts because ultimately when you have these root exudates, they help assist in nutrient uptake. They help assist in,
and I love how Josh popped that back up.
They help assist in improve yield.
So I like this, and this is for the people that may be listening. But I love it how Josh does. Like when he hears something, he goes, "I'm not sure what that is." He automatically plops it up, and I think that's great because he believes if maybe he doesn't know it, then maybe some of you don't know it as well. So sometimes we do forget that. So what is a root exudate? These are fluids that are emitted through the roots of plants, which I think that was probably implied. But these secretions influence the rhizosphere and attract these things that we're talking about, right? And what that does,
it is how it sounds.
Well, it does how it sounds.
That's why, and maybe that's why I didn't.
But that's a little bit of a word. It's a weird word.
It is how it sounds.
It's a weird word, So ultimately, what the heck does that even mean? It's going to increase nutrient uptake because of these associations, because of the symbiosis. It's going to enhance stress resistance. It's going to improve yield, which is really what we're looking at, and then ultimately also
and quality.
Quality.
And ultimately, again, making those elements more efficient, making them work better. Right. When you add these carbohydrates, even though it's not adding EC to your things, it's making the elements that you've already provided work better, which again, it's so funny to me how people just continue to stack and stack and stack, where it's like, we've determined over years and years and years, hey man, I can get the results that I need out of a 2.224 EC. I don't ever want to see a 3.0 EC. I'd rather just give it sugars and give it,
well, it's funny, give it a correct rhizosphere and give it a healthy rhizosphere.
Well, but we talked about it before the episode and we were like, do we talk about the fulvic? But ultimately the sugars in the fulvic and make all of those
symbiotic situation as well.
Make all of those elements that we're giving the plant work better.
And the one thing I do want to mention too, of course, is that, and this is to kind of tie it back to that last segment too, but this, the one of the ways that the plant actually regulates that sugar exudation is via circadian rhythm.
Yeah.
So, and that is that diurnal, right? Which is just a different way to say that, but that is that day and night, right? Which creates, different pressures and different things going on and stomata opening and closing and just a lot of different things.
I saw our buddy, Rasta Jeff at the fish shows.
Shout out to Rasta Jeff.
I get a picture of Banner, Rasta Jeff, and Gabe all hanging out
randomly.
That happened completely randomly.
Goddamn hippies.
I told him I was, I led off the conversation by saying I was friends with GRAMBO.
What the hell, dude?
And then I was like,
I know where we're at now.
And then I was like, oh, by the way, I was like, I'm one of the Jug Dealers. No, he was actually keen to mention you quite a bit. Even after I told him I was a Jug Dealer, he was still pretty keen to mention you. But we had a very good conversation about the circadian rhythm in which Jeff, because Jeff,
I picture these guys at a concert talking about plant circadian rhythm.
This is before the show, but it's funny because you and I have had the discussion about how Jeff likes to do 18.6 at the end.
Yes.
And, I have my opinions.
Gabe doesn't love it.
But when I actually I talked to Jeff about it and I told him my reasoning as far as doing the 1812 and reading what these guys did in the 90s, he loved it. And he was like, I'm going to do that the next round. He was like, I'm going to do the 1812. And he might even do. So for any of you who haven't followed me that long, there was a group in the 1990s who did 1812 the whole round. And the argument was they were able to harvest in 45 days, but the plants had gotten 60 days worth of light, in which you've always been keen about the circadian rhythm being, they need 12 hours. They need 12 hours.
Now
the problem with that is your lights come on at a different time every day because it's 4 hours different. Right. So it's hard for people to work in that. Now, if you take into account, you still have 18 hours of light, you should be able to figure it out.
I agree.
But it was funny because I mentioned it to Rasta Jeff, and he was like, dude, I get it, and I'm totally going for it. So I'm really eager to see what he does with it.
Well,
Shout out to Jeff for sure.
And I don't want to get too far in this, and I know I've mentioned this at one point in time, but I even at one point dropped it in the opposite direction, and it literally was almost like chilling hours, like in a weird sense. And I don't know why I even make that correlation, but if I were to, because I was doing 4 hours less of light a day, say some light in the middle of the summer, well, I had to run 2 weeks longer. When I did the math, it was the same amount of time, same amount of hours with the light on. So going the other direction actually makes sense to me as well. It really does. Last thing I do want to mention about, just carbs in general is that they really are kind of a currency again, like we talk about for that microbial exchange. This is an exchange process. This is a symbiosis.
There's so much, again, with covalent bond and, microbial exchange, we always say it's a bank. It's giving and taking, and
at the end of the day, the better the sugar quality, the better the mycorrhizal colonization.
And going back to Liebig's law of minimums, wherever you find that minimum, wherever you see that minimum is where. So whatever your limitation is, and whatever limitation you're providing is where you're going to be like, oh, okay. Why doesn't my weed have a lot of flavor? Well, I'll tell you why it doesn't have a lot of flavor, because you're not using the sugars.
Sure. And again, it's never just one thing, folks.
No.
It's always again, ratios. It's always interesting.
I think one of the things I really enjoy about working with you is I think a lot of people don't think outside the 17 essential elements. I really don't. I agree. I think they're so one-sided about it, and not for nothing. This is a good use of that one today, but not for nothing.
That sure will be up there too.
Everyone is so just cost oriented and overhead oriented that they're like, oh man, but I got it down to 5 cents. I got it down to 7 cents. Do they even know what they're growing? And the thing,
do they know what they're growing?
Well, and
they might think that they're growing plant matter, but we're not corn farmers here, folks. We're oil farmers.
And what we're keen to point out to a lot of people too is that
there you go, grow oil, not corn. There,
right.
That
7.
There you go, Iowa boy.
Or that's 7 cents a gallon.
What?
I am too.
That 7 cents a gallon a lot of times is a 1.0 EC. So if you're running a 3.0 or 4.0, you can multiply that.
They get sneaky on the marketing. You know, everybody knows that marketing is sneaky, and that's why we try and throw some authenticity in this thing and just give it to you guys straight and take it from there. All
right, so, let's go. Anyway, we're going deep in the rabbit hole. I know this was really a focus for you.
Yes.
Especially because you've been spending a lot of time with Thomas. You've been talking to the Slicium guys, and this is one of the really special things about Slicium. But why don't you dive into the
Oligosaccharides. So again, any of these acarides, these kind of words, they're going to be a sugar of some sort.
IDE, OSE, IDE.
A lot of these things are obviously, and actually, why don't you just, pull that up, a little bit and give a definition of that there, Grandma. I saw that you copied and posted.
But these are sugar messenger.
And one of the big reasons that I wanted to talk about it is this is one of the products that does make, Slicium Bloom unique to Slicium and unique to other products that are out there. This is something that people don't talk a lot about. And, obviously
probably because they can't say the fucking word.
Well, that's the start. That's actually, I didn't think about that now that you mentioned that. So while simple sugars like glucose and sucrose fuel energy and growth, oligosaccharides are actually short chains of sugar molecules, but act as vital signaling compounds. So they're not the same.
They trigger that SAR response.
That's
basically
one of the things that they do among many other things, but there are signaling compounds.
You love talking about SAR as well.
I do. Dude. Yeah. So just systemic acquired resistance is one of the things that I do like, because it's like, how can you acquire these stress responses to get oil production, right? And terpene production. And 2, how can we do it to actually, pre-harden our plants to defend themselves before they get what would normally happen in nature, which would be an attack by either some type of pest or disease, right? So things like this, or even like harpin proteins, there's a few things out there that can, kind of elicit these sort of plant defense, responses in this microbial
So it's really priming that immune response.
That's exactly what it is. I think that's a really good way of saying that, actually.
Yep.
So oligosaccharides and this is a good one, oligogalactoturonides. Try that one 3 times, guys. Oligogalactoturonides, and that's a real word, and fructooligosaccharides trigger systemic acquired resistance specifically, which is known as SAR, which helps cannabis plants fend off all pathogens by, again, priming that immune response. So it's just getting you ready before it happens. Is it going to happen, after they've been attacked? And, yeah, but if we can do it before, why wouldn't we? And again, to go back and remind us, well, if the plant thinks it's defending itself, maybe it puts out more oil.
Yep. Yep.
That's what we want.
You know what I find interesting? I find it really cool how some of the mycorrhizal fungi will they'll recognize specific oligosaccharides.
Yes, they will. And
it will actually give them the cue to initiate symbiosis, particularly during.
It's like right over here, guys.
And it's funny because we talk about so many times about how there's all these things that they just have one freaking job. You know what I mean? Just to send one signal.
Yep.
But, I can't remember what episode we talked about, but it was like, without this certain enzyme, it takes, hundreds of years for something to happen. But then all of a sudden you just add this one thing and it's like, it's instant. It's just that trigger it needs.
Yep. And I love and I wanted to also mention this, right? Because one of the things I always like to call Slicium, as you see it, like literally we're right. There it is. It's hard to see it. It's hard to see it on camera.
Hi, it's right here. Hello.
I love to call this liquid insurance, guys. And the reason is, because it does reduce any abiotic and antibiotic stresses. So,
and that's one of the big differences between the Slicium and the Slicium Bloom is the Bloom has these oligosaccharides.
It has these oligosaccharides, absolutely. Now, in general, by having that bioavailable monosilicic acid, which is what it is, it's a stable monosilicic acid, stable MSA that's readily bioavailable.
There's a lot of silica out there.
But not all them are all readily available.
Yeah,
I'm not going to point out anybody.
I'm not trying to touch on anybody, but it is a funny thing because that availability is just so important.
It's incredibly important, right? And we're able to add that first to our reservoirs and have it readily available because it's water soluble, so it gets right up into mass flow. It's taken right up, dumped in the cell walls, and then the rest of it, because if you look at it, it's just SiOH4. So the H2O that's called transpiration, folks.
Like I say to folks, man, put that stuff in first and put your hand in the water. It's almost like more slippery.
Like a glove.
Slicium changed my life. I hated silica. All the fallout, all the nonsense. Right. It's barely available once it's even in there. Slicium's Silicium and Plague Green Sensation. Those are my secret weapons. Just saying.
And again, that's why I call it liquid insurance, right? Because again, it's going to reduce any abiotic and abiotic stress, and specifically in the stress recovery or stress signaling and recovery under those abiotic stresses, which would be things like heat, drought, light, intensity. Oligosaccharides specifically help signal these protective gene expressions, acting as a biochemical early warning system. So again, really, really cool, really, really complex stuff. Always also has a prebiotic effect in soil. They feed beneficial microbes while discouraging pathogens, believe it or not, which is wild. So it really serves as a targeted food source as well, which again, this is super complex stuff. We wanted to, try and touch on the top level of it, but
hey, everybody, just wanted to remind you that if you want to try any of the products that you see us talking about or using in our own gardens, go to jugdealers.shop. And now back to the show.
Try and touch on the top level of it, but it's like the more I scratch into this stuff, I'm like, the crazier it is.
When you were on Jug Dealers the other day, I was talking with Scotty. I was like, even if Gabe, because you said it's like, oh, I had a brain fart there. I was like, even if you didn't finish your thought, you asked questions that get people asking questions. Then they start leaving comments, answering our questions. Leave a comment. Do you know more about this than what we're talking about? I want to know.
Oh, we love. And by the way, on the auto flowers, I'm glad you mentioned that, Josh. And I don't have anybody specifically to name because so many people popped in with great comments. Message me through the Jug Dealers website, like, hey, this is how I feed autoflowers. This is an important thing about autoflowers. Hey guys, thank you for that a lot, because that's the kind of interaction that we want. And in fact, we're really going to work on leaving a segment at the end of these shows where we answer a question or two, where we really have that regular listener interaction, because that helps drive
I'll throw that call out there. Leave if you have a question about anything, leave it. We might just be doing that segment every show. We might end. You
never know.
Instead of just doing viewer interactions, we'll answer your questions.
So to finish up this thing, the one thing I'd want to say, unlike put a bow on it. Yeah, let's put a little bow on here. Unlike basic carbs, which again, basic carbs are not bad. That's what we started talking with. These are just very targeted, right? So unlike basic carbs, very specific. Unlike basic carbs, oligosaccharides are not used for energy. Rather, they're used for signaling.
Yep.
And they're used for information, right? So think of them as, almost like little text messages, the root zone kind of, which is kind of a funny way to think about it. But the point is that it's really short, it's really precise, but it's also very crucial for these plant microbe relationships, right? So would you just kind of spotlight specifically Slicium bloom? Again, we've kind of mentioned this a couple of times. The original Slicium is totally fine to use in flower, but Slicium bloom has been very specifically formulated for bloom. And in fact, I'll make this mention real quick before I let Gabe go in that we like, carbs being used the whole time, but really the most crucial time is at mid to late flower, like you were saying earlier, which is what you kind of see where the Slicium bloom is as well. So Gabe, why don't you go and
look, the oligosaccharides along with the polyphenols are two of the things that make Slicium bloom different from the original Slicium, and quite frankly, from every other silica product you're going to see on the market. They help promote terpene production. They help initiate defense systems. As mentioned before, increasingly enough, the oligosaccharides come from seaweed and polyphenols from the pine tree
extract. And you're not going to see this. You're not going to see this in print anywhere.
And you are not going to see some print. That does explain. I wondered about the color. Because if you'll notice, the regular Slicium is kind of a clear.
Yep.
And the bloom is actually a little bit thinner, but it also has a little bit of color to it. That's where that color is coming from.
Yeah. So next segment, and that's the original Slicium, but we also do have the Slicium bloom. There she is. It's a little bit of the red tint, which is kind of almost gives a little bit of an idea of what the color is, even though the other one's not at all orange.
And I'll just say very affordable. Not only is it cheap, it lasts forever.
Half a mil a gallon.
Yeah, half a mil a gallon if you're running it in the root trench, 2 mils a gallon for foliar. You could spray it as much as you want.
Yeah, you could definitely. I mean, I've
foliaring silica, people. That blows my mind.
Well, and that's
but it's also going right to the
where you want.
It's almost a preferred way to apply.
Yeah.
Well, I will say, after sitting down and our partners will remain nameless, but after sitting down with some of our people and really quizzing them on that, they said that look, fuller, because ours it's so small because they're actually they're stabilized. Again, I told you it was a stabilized monosilicic acid, stabilized MSA. It's actually stabilized in monomers, dimers, and and trimers. So 1, 2, and 3 cells of monosilicic acid. So because it's so small, it can actually get in. Not only that's what makes it water soluble and bioavailable, but also it's small enough to get through the pores that are through the cuticle layer, through the leaf, and actually be uptaken through the leaf. So it's kind of almost a mechanical thing. They're just small enough molecules to be able to actually get in. So there you go.
Can we talk about nighttime metabolism and sugars at night?
We can, because again, like we talked about,
I don't think people think about the night.
No, I think everybody thinks everything's.
They're like, oh, they go to bed, nothing happens,
and it's not that we can do a whole lot besides potentially some day and night manipulation, like we alluded to before. Obviously, stabilization of your humidity when the lights go off, some things like that. Potentially even another alluding to our movement episode, but maybe even taking that air movement level down at night, because you don't have the stomata open. So you don't need the same gas exchange. You don't need the same reduction in boundary layer. Yep. And also the plants just kind of like, let them rest, man. Let them rest a little bit. So these things are all, to be thought about, and anyway, so let's talk about the hidden engine, which is the nighttime metabolism of sugars. So at night, again, like we said, cannabis does switch to dark respiration, which is starch broken down to glucose. Glucose is used in mitochondrial respiration, so it is that ATP cycle essentially, which is not only important for cell division, trichome reduction, lignin, secondary metabolite biosynthesis, but a host of other things.
And it's not taking in CO2, so there's not.
No, because the stomata are closed at that point, so they're not really drinking water. You don't really have transpiration going either, because just to remind everybody, plants don't drink any water. It goes in the roots, it goes up through the plant, and it goes out the stomata.
Little nappy nap time.
So if the stomata aren't open or a plant isn't transpiring fully, it can't drink any water. It also can't be taking up any nutrients because the nutrients come in with the water. So
you just did that hand gesture there, Gabe. Can I ask, are they losing turgid pressure? Is that why they droop like that, or are they?
Honestly, it'll depend on the genetic. Obviously, sometimes you'll come in and you'll just see your plants kind of like.
But there's also, and I can't remember. It's like called like phytomorphology or something like that. The fact of the matter is, they're keeping their solar panels up and to the light. So, or even sometimes when you see there's too much light, they'll turn away from it. Right. So they do have an ability to, take in and leave it. But at night, it's kind of like not that big a deal. But I do think that some people, I see it more genetically than anything else, as Gabe mentioned. But some will like just straight up almost like a prayer plant, or almost like one of those sleepy plants.
Like literally, it's like, oh, you fell asleep.
Yeah, but then that next day it's like, so I think people might mistake it for a lack of turgid pressure, but it is not actually.
Yeah. I mean,
all right.
Yeah. And you can see the difference for, if you were to compare it to a plant that's like dry, let's say.
Oh, absolutely.
Because it still has that like, rigidity in the petiole. And the leaf still has.
It's not like this. It's just like this.
But
does that make sense?
Well, and the thing,
fascinating.
And without the light, the plants are going to pray like that. Right. They're going to go towards the light. So just without that light.
And just to again stress, how important carbs are truly at night. If carbs do run out at night, that means that the plant's going to enter carbon starvation, which is going to lead to stress and ultimately flower abortion. So it's not what you want. It's obviously not what you want. It's not what you want.
Moving on.
Let's talk about carbonaria. Because carbonaria is, that's our carb product.
That's our carb product.
Carbonaria. It is 20 different direct plant extracted sugars. So we're going to talk a little bit about, what is carbo, and then also what makes it a little bit different, not only to other, sugars on the market, but even specifically talking a little bit about molasses, only because that's always been looked at as kind of an old school standard.
The old school.
It's like,
same but different.
Yeah,
kind of. Not even.
It's like potassium silicate to monos.
It's
similar.
So
not the same.
So
no, I'd say it's the same. One's going to be available form. One's going to be non-available form. So
molasses is one thing. Carbonaria is 20 different plant extracted sugars. And the most important thing is because it's gone through that fermentation, that Bokashi method fermentation.
That's the high availability.
Everything is readily available. So the plant, the big difference is with molasses, the plant's got to do work to make it available. Whereas There's no work that needs to be done on the Carbonaria. It is it is
it's readily
ready to
available
go.
as plant and microbe food.
I was going to say
and micro food.
Because a lot of people are feeding their microbes with molasses, but again, got to do a lot of work. To make it available.
A lot of energy. Can you move that up a little bit there, Grambo? Thank you, sir. All right. So, Carbo, what is it? It's New Millennium's, like we said, our highly bioavailable product, right? It's an additive, so it's not a part of the base nutrient line. Specifically, it's engineered for late bloom energy support. But again, when you're supporting that microbial situation and contributing to a healthy rhizosphere, I use it all the way through veg, all the way through flower. If you were being budget conscious, like we mentioned, you could, let's say, use it at lower amounts at those other times and really crank it up a bit in that.
I got a lot of guys who are running we'll call them the salty boys, but they're doing like a New Millennium additive feed once a week where they'll do Carbo, Fulvic or the Fulvic.
I love it.
Saucier base.
So they are saucing the base because they know that's where the flavor is.
Run your base and run our additives.
No problem.
It's a winning combination.
And the other thing too, I want to highlight for everybody is, because we get this question more than you could think. It's safe in cocoa. It's safe in living soil.
Oh, it's wonderful in both, actually.
Here's the
particularly.
Question. Well, here's the question for you, because a lot of our living soil friends, they worry about OMRI. And it's not OMRI registered, but
we're a small independent, folks. I think you guys understand that by now. I can look you dead in the eye and say, look, it's an all natural product. It's going to be perfect for living soil systems. It's going to be perfect for organic systems.
OMRI's expensive.
OMRI's expensive. You know what I mean? That's just all there is to it. What we're giving you, again, it's multiple sugar forms. It's designed for those peak metabolic periods. And obviously, as we just went through with carbs and oligosaccharides and everything else, it's going to push that resin oil production, which again, we are oil farmers. So we get to do that without stressing the plant. So it's like giving them stressors, or the essence of stress. You know what I mean? Again, that's why we call them positive stresses, because they're positive stresses for us because we're pushing oil out with that stress response, right? So also using it during those flush periods when the plant still needs some fuel to finish strong helps unlock anything that's left in that rhizosphere. So I do like it at that point too. I don't think it's
because it has no NPK, right?
Correct. It's 0.3. I think it's a little bit of potassium. So virtually no. It's truly an additive. It's truly an additive.
Like many of our additives, the EC is extremely low.
There's almost nothing.
What's in it? And you're like, well, there's really nothing in.
Some people will, because some people just really like doing sugar, especially early. Some people will do it as a fuller as well. I'm not particularly interested in doing that, and I drop it down to maybe 2 mils a gallon, something like that. I particularly use it as a root trench, 5 to 10 mils a gallon.
Well, and the other thing is too, not cannabis specific.
Oh no, not at all. Oh God, no.
Use it on your. I use it in my. Tomatoes,
I use it all over my garden. I use it on all my flowers, everything else.
Yeah.
Use it with the fulvic acid.
Use it with Mad Garden.
Use it with Mad Garden. Use it with really any a compost tea, anything like that. Hum tea, something like that. I mean, anything like that would be fantastic. So one of the specifics, though, I really wanted to talk about, because this is a question that we get. So this is kind of almost a listener action without being a listener interaction, because we're really going to talk specifically about why Carbo is better and more available than molasses. Take it away, Gabo.
Molasses has been long used as a source of carbs. Primarily for feeding soil microbes.
Yep.
While molasses does contain simple sugars and some micronutrients, it has significant limitations when compared to precision formulated products like Carbonaria.
Absolutely. I mean, and really, it's a big part of it is that purity and consistency. That's one of the big reasons. This is, just like you said. I mean, it's a precision formulated product.
And we got new equipment. It's actually, for any of you who've used it for a long time, you'll remember, a couple years ago, it was pretty thick.
Oh, it's real thick.
And with the new equipment that we have, the new blend, we didn't change the formulation anyway at all.
Nope, it's really just how we're able to mix it and blend it.
Yep. But it is a much thinner product now. It's almost like a coffee creamer.
Yeah, it is. And here's the thing, and obviously it's small batch for us. It's one of the reasons we're able to do really well with it. And something like molasses,
3,000 gallons at a time, I think.
So whereas molasses is, it's a byproduct of sugar refining. So the impurities, and because it's coming from all over the place, the impurities and imperfections are going to be high and depending on the source that it's from. So it really is, you're taking a bit of a chance there. Whereas ours, again, it's 20 different direct plant extracted.
They're like, they're a bunch of those. I mean, I know the ones we have on the label, those are like Neil's special little.
Well, there's only 7, I think, that we have listed on the label, but those 7 you'll probably never have heard of or find anywhere else on any other bottle.
We can't even describe. So we can't even put them up here because we don't know how to say the goddamn thing.
We've got, we've got the normal ones too, but I think we only list 7 on there. So anyway,
and then the other thing that's really important is molasses can actually promote microbial blooms. For a lot of you guys who are in, really in any facility, you're measuring CFU, you're worried about these kinds of things. So this is a much better choice.
And it just creates weird pockets in soil and cocoa. It's just not, again, it's kind of a lack of consistency. It's super sugary. It's very thick. It's hard to blend into the water. Again, something like you mentioned, it's like a coffee creamer, the carbo is. So
honestly, it's funny because of all the things I feel like we sample out to people and I've let people try over the years. I get a lot of really good, it runs the gamut because you can give it to a wide range of people and they always come back to you and they go, man.
Oh man, whether we're at a lawn and garden show or a hydro show or wherever. I mean, that's always one that we go and sample out.
It's in sample pack number 1. So if you guys get it, you'll get a pep pack and you'll get to try all these things. So
perfect.
What we say, $600 value for $95.
For $95, it's right there.
That's essentially ship. That's the pep packs are huge.
If you were to go to the store and buy that retail, it's quite a bit.
Yeah.
There's like some cocoa blocks in there.
There's cocoa blocks in there as well.
There's something for everybody.
There's something for everybody. So pH stability too is worth mentioning. Again, depending on where it comes from, that molasses bottle to bottle, company to company, that's going to throw it off. Again, the carbo that you get's always a carbo from us. So it's going to be a lot more. It's basically stabilized and buffered. So it's going to work with any modern nutrient programs, obviously including the full new Millennium line, but also whether it's Scietetics, which is also another of our lines, but also anything that's out there. Our proof in that is, the saucer-based schedule that we've had for many years. So, again, in short, carbo is a precision fuel. Molasses is an old school additive. Not bad, but it's just not really for advanced water. Yeah. It's not an advanced cultivation. And really, I mean, thank you. Carbo isn't just sugar water. And I think really the whole point of this entire episode is that, high quality carbohydrates in general, which carbonaria is, it isn't just sugar water. It's any high quality precision formulated carbohydrate is a fantastic tool that is going to enhance sink strength, like we were talking about. It's going to boost late stage terpenes and it's going to accelerate floral ripening. So if you're really serious about growing resin and being a resin farmer, then don't starve your plant of this stuff. It's really important.
If you're a hash guy or concentrate. I didn't say
How far
that.
in are we?
Mark edit 45 minutes. Yes. So we said concentrate.
There's a war against the things.
There's a war going on.
So we've got one last, and we've been rocking along. This has been a great episode. I've actually really enjoyed this. We've got one, last little section here that we want to talk about, and it is specific to terpene and cannabinoid production because again, this is what we do. We are oil farmers. We wanted to mention that terpenes are isoprenoids, which again is another fun word. That's maybe one that GRAMBO can look up for us.
I was already.
Come on it, boys.
So while he's doing that, obviously glucose feeds into the pathway via glycolysis. THCA and CBDA synthesis begins with acetyl-CoA, which is also carb derived. So really what that breaks down to, high sugar equals high carbon skeleton availability, which equals higher secondary metabolite potential. So these are the things that we really want to talk about. So the terpenoids, also known as iso
organic chemicals. That means it's carbon based.
When you type it into there, it just autocorrects it to terpenoid, like redirected from isoterpenoids,
aka terpenoids.
You're talking about stuff that Wikipedia don't know nothing about.
Isoprenoids.
You guys are killing it today.
So obviously, when we talk about this, you can move that up just a little bit there, Josh. The big thing that we're showing is that studies are showing that these things in these available carbohydrates directly correlates
trichome density,
cannabinoid content, especially and particularly
two of your favorite words,
THCA And then also monoterpene and
Come on.
sesquiterpene expression.
You'd be excited.
So this, these greasy versus these sandies and some of these different terpenes and different things. And, it's one of the things we talked about on actually the Robert Clark episode that I did. I think it came up kind of late in the episode.
Go watch that episode. Y'all are slackers, man.
Please go watch it. There's some nuggets in there.
It's fascinating because it just dawned on me. It's like I've known about like the monoterpenes, and that's why. Is that why it's a trichome?
Now we're getting somewhere. All these things, you got to understand, all these things are chemistry terms that if you know the terminology, you can figure out even like, if you really know chemistry conventions, the word alone is going to tell you the chemical structure.
Well, that's like I was saying
That's
about
the whole point.
The OSE, OSE.
Or,
if you have,
or ACE is an enzyme.
Yeah. OSE is going to be a sugar, right?
Or OID, I think.
Glucose.
No, OSE and glucose, sucrose, and then
they're all
then
sugars.
it's like a type of sugar.
Yeah.
So again, these are all conventions. These are all language conventions, all of which I don't know, by the way.
They all come from our favorite friends, the Latin.
Again, the real practical grower takeaways here, the timing, I think timing is really important. I did want to mention that it's always beneficial, but again, if you have to, if you were forced to reduce that a bit, that mid to late flower is really when you're going to want to do that. Don't starve it during flush, also pair with those microbes.
Pair with the microbes. That's one of the biggest things. If you're doing microbes, don't do one without the other. That's one of the big things because you got to feed your microbes.
And and again, remember guys, this whole, that breaking that sugar down at night and that dark respiration, everything else. Well, guess what?
That's a great tip.
This is a great tip.
It's a great tip.
This is something.
If you take anything away from this episode,
this is something we came through.
Away.
So little pro tip: fuller feeding at dusk. Why? Because all that stuff happens at the dark. And so applying those carb blends as a fuller at the end of the day supports that nighttime metabolism. That is something that I had never really thought about, hadn't considered. And I think for some of those guys that are really doing some of these like interesting extra things that some people go, what the hell are you doing, dude? Like this doesn't make a whole lot of sense. Well, maybe it does, guys. Like maybe it does. So look, at the end of the day, I think we could all agree that carbs are more than just a sugar. It is a full growth strategy.
Yeah, it's a strategy. It's something you really want to be dialed in with. You want to take notes.
Yeah.
And say, hey, we did this, again, talking to the diamond mine. Hey, I did this ferment. I did this carb. I did this whatever on day 7. Yeah. Not day 8. Right. Not day 6. And
it does. They do multiple things. It is flower fuel, but it is a major driver in that microbial symbiosis, which is an interesting thing. We sometimes, I'll be honest, I even thought at times, well, those associations just happen. Well, do they? Or are they going to go where it's more advantageous? And are they going to go the path of least resistance? Well, turns out. Yeah, that is exactly what happens. So don't look through, don't overlook these foundational inputs. Shout out again to Carbonaria for New Millennium and also Slicium Bloom, which does have those oligosaccharides. I don't think anybody's brought that one up before. We've talked carbs before, but who's talking oligosaccharides? And I wanted to mention next week's episode. What do we got coming up, Gabe?
Next week, we have an episode. We're calling it Wind War Airflow. Battles in the canopy. Nobody we're going deep into it because a lot of people, I think there's a lot of things people overlook. I've actually been in a large scale grow. We are talking 100,000 square feet where these guys had a chiller system in their building and they had no fans in the room.
None.
And I can tell you, I'm not going to call them out. I'm not going to tell you what state they are, even though it's back east. I'm not going to say it, but they battled powdery mildew. They battled all kinds of issues, and so we're going to go deep in the rabbit hole on that one. We are psyched for you guys to come back and join us as always.
Last thing I'll also say, if you do have any questions specific on airflow, this is your chance. Again, we had so much fun. We kind of ended up with a longer episode. You never know. And this one just, anyway, we are going to try and have a couple episodes, 1 to 2 questions at the end of every episode that does pertain to the episode. So if you got a specific question on airflow, put it out there. You never know. We might answer it. Till next time, guys, from the Jug Den. Had a lot of fun today. Peace out.
Peace.
See you next time.